There's also what's called another AC motor. It's called a synchronous motor. Well, the difference between a synchronous motor and a standard induction motor is that a synchronous motor has coils on the rotor. There's coils here on the rotor, and you have what they call slip rings, and power is brought in to the slip rings to power those coils with DC. So what happens here? Well, now you have the magnetic field without any slip. So synchronous motors run at exactly the frequency that you're sending them. Okay? So you don't see synchronous motors very much, except in really big, on really big motors, 100 horsepower, 1,000 horsepower, that kind of thing, because it's way better. It's much more efficient than an induction motor, because the slip induces heat and so forth into the rotor. So a synchronous motor, you see them in really big operations. Now, today we have another kind of motor, which is permanent magnet motor, AC motor, and they're just starting to become really popular, primarily due to the fact that we have much better magnets now. Okay, so in a permanent magnet motor, they put permanent magnets in the rotor instead of coils. And so now that motor is a synchronous motor as well. So its efficiency is higher and it runs at a synchronous speed. So if, say, you're driving a conveyor and you'd like the conveyor to run at an exact speed, a permanent magnet motor would be a good choice. All right? And the permanent magnet motor is 5 to 10% more efficient due to the fact that it's not losing any power in the slip. So that's right. So now there's also single phase electric motors, and the way you can tell, single phase AC motors. The way you can tell you're looking at a single phase motor is that normally, or often I'll say, you'll see a bump on the side in addition to the wiring, and that's holding a capacitor. And there's two ways that you can run a single phase motor. One is capacitor start and the other is capacitor run. Capacitor run motors are typically used for stuff where you don't need any starting torque, that you just want to get the motor running. Why do you have a capacitor? Well, you only have single phase, and so there's not a natural rotating magnetic field. So what the capacitor does is shifts the phase of the start of the one winding with respect to the other, and that creates the rotational motion. That's why you have that capacitor. Now, in a capacitor run motor, you'll see them on things like a grinder, where you don't care that the grinder comes up to speed slowly and that kind of thing. But capacitor run motors don't have a lot of starting torque. So you'd never be able to run, say, an air compressor with a capacitor start motor, or capacitor run motor. Okay, so then they have capacitor start motors. Capacitor start motors have a starting switch that's centrifugal built into the motor, or they have a relay outside of the motor is a time delay. And what it does is it energizes this set of coils through the capacitor, and that produces a whole bunch of torque starting up. So that's what you'll see on an air compressor that you get from, say, Home Depot and stuff like that. You'll see a capacitor start motor. Now, capacitor start motors have a lot of starting torque for a short period of time, because as soon as they get up to speed, the centrifugal switch or the time delay switch turns off the starting coils. All right, so then it's running by pure induction, and that's how. So it works that way. So the downside to capacitor start is that you need this starting relay or the centrifugal switch. So you would never want to use a capacitor start motor on a load that was going to be turned on and off all the time. If you're trying to do, say, move a conveyor and stop, move a conveyor and stop, the motor wouldn't hold up, because every time it starts and stops, you'll hear that switch click in and out, or the thermal relay will click in and out. So in general, Single phase motors are for the less technical uses. You don't in industry now. You almost never see single phase motors being used for any of the equipment that they have. A big reason for that is that these VFDs have another trick. They can take the single phase AC power and turn it into three phase, all right? And it's kind of a convoluted process. The first step is they turn the the single phases of AC into DC, and then they use switching transistors to turn it back into three phase. But that means that even in a place that doesn't have any three phase, you can use single phase power and run all three phase motors. I used to build waste treatment plants. All the plants I built, they were small. They all ran on single phase power to them because our customers frequently did not have three phase power. But all of our motors were three phase by virtue of having VFDs. Now, because the VFD could control the speed, that also meant we could control the flow of pumps and how much air we pump to the system. And so this is becoming a hugely dominant way of running motors. And contactors are kind of being left to just things that you can bang on, bang off, and you don't care. So, all right. So there's another couple types of AC motors. There's also what's called a shaded pole motor. And these are like a clock motor you'd find in a clock or something. They run very close to the synchronous frequency, and the way you can tell a shaded pole motor, you never see one with a housing. It's always like an open windings, and you'll see this like piece of heavy copper wire running across the face of the motor. That's how you can identify it. They're low torque. And they're used in really small things. And that's about the only way they're used. So that covers all of your AC motors. So then, so one more thing. So with a good VFD, in other words, one with high capabilities, and an induction motor or a permanent magnet motor, you can do position control, but it's not going to be real close. It's low. So you would see this used like that combination used for, say, an elevator to raise and lower something, and where you don't have to line up within an eighth of an inch or so. You can't get super accurate thing, and you don't get good reversing capabilities. Like if you come up and you overshoot, it's not easy to get it to just back up a little bit, because there'll be a point at which it will hold no load.